Chapter 3, Day 3 notes, quadratic functions. Make sure you have a calculator on you just for a bit. Also, I'm going to have a specific request in this video. I'm doing a survey in AP Stats. So if you could, just comment on the comment section on Schoology for this video and say, just tell me what your favorite color is. I'm doing a survey in AP Stats. So just comment on the comment section, tell me your favorite color. Anyway. So, what about quadratic functions? You should know their graph pretty well by now. It makes a parabola. So what about that parabola is important or interesting? Well, it can have 0, 1, or 2 solutions, or graphically, those are the x-intercepts. You call them zeros, you could call them roots, and again, you could also call them solutions. You could have 0, 1, or 2 answers, basically. So all three of those words are synonymous with answers and solutions. X-intercepts, graphically, they're the zeros, they're the roots. So let's make a rough sketch of that. Let's draw one with 0 solutions. So this one would have no real solution because it doesn't hit the x-axis at all. So I just drew a sketch of a parabola above the x-axis. This one would have 1 solution because it only touches the x-axis once, hits it right there. That's 1 solution. Then 2 solutions, you could draw anything that hits it twice. So I drew one down. That hits it twice, so it's got 2 solutions, or 2 zeros, or 2 roots, or 2 x-intercepts, however you want to say it. Okay, so first example here. I want you to graph the following in your calculator. This is the only time you'll need a calculator for these notes. But I want you to graph the following 3 graphs in your calculator. So here's the first one. 1/2, you can just say 0.5 x squared plus 3x plus 2.5. Graph that one. And then graph this one. And you can do this like, this could be y1, y2. And then graph this one. So yeah, I'm actually even going to say you can graph them all at the same time. So graph this one in y1, graph B, graph that one in y2, and just graph this one in y3. So you can graph them all at the same time. Okay, so I know you've already got your graph in front of you. That's excellent, that's great. I'm going to take a look at a graph myself and see what I come up with here. So let's go to y equals, and then I'm just going to say for the first one like 0.5 x squared plus 3x plus 2.5, because then I don't need parentheses and then I don't have to write a fraction. And I already typed all 3 of these in here, but since I only highlighted this one, see how the equals sign is highlighted on this one? That means it's only going to graph this guy. So we know it's going to make a parabola. It's going to open up. Looks like that. Vertex, I think, is -3, -2. The zeros, I think, are -1 and -5. Okay. And then let's turn on the second graph here. So I turn on y2, hit graph. Looks strikingly similar. And then what about y3? In fact, I'll just turn all 3 of them on at the same time. And if it's the same graph, we'll know for sure. So there's y1 on, y2's on, and y3's on. Now I'm just going to hit graph. What do you know? We only have one graph on here of a parabola. Okay, so what does that mean for all three of those equations? All three of these equations, and I'll go back to the notes here, whether it's written this way, or like that, or like that. In fact, these all make the exact same graph. So these all must be the same thing, just written in different ways. So technically, that is equal to that is equal to that. Maybe the algebra is just a little bit manipulated in each one. Okay, and the reason I show you these three is a very specific reason, because these are the three different ways that you can write a parabola. So they're all three the same graph, written in different forms. This first one, part A, you should be very familiar with that. That is standard form. And just to be thorough, let's make a sketch of these. Let's make a sketch of this graph. So here's my parabola, and then I'm going to put the critical points on here. And you can find these in your calculator easily. Second trace, minimum, second trace, 0. You can find all these. So the vertex and the x-intercepts and the y-intercepts. So the vertex was at -3, -2. The x-intercepts, -5, 0, -1, 0. And then the y-intercept was 0, 2.5. So you should sketch this graph. They all three made this graph because they're all the same thing. Okay, so let's talk about the benefits of each type of form. One more thing I want to add to the graph, though, and you saw this in Algebra 2, axis of symmetry. So the line that cuts it right down the middle, vertical line, looks like it's here at x equals -3. There we go. Axis of symmetry, the line that cuts the graph straight down the middle. You know my graph, my drawing is obviously perfectly symmetric. And since it's a vertical line, it's just x equals -3, which does have something to do with the vertex. That's a little bit of a review from Algebra 2. So the axis of symmetry, line that cuts it perfectly in half, just a dotted line. That's x equals -3. Okay, so which form is best for which one? So standard form, that's the very first one. Standard form. Okay, and the general form for that is just y equals ax squared plus bx plus c. Notice I just left the numbers in black. A, b, and c, those are all constants. This type of form is called factored form. Factored form. So 5 and 1, what's special about those? Those are the zeros down here, right? If you solve those are the solutions, those are the zeros, the x-intercepts. If you solve them at 0, you get -1, -5. So that's factored form, and again, you saw that in Algebra 2. So the general form for that is y equals a, the same a values you saw over here, and then the 0, and then the other 0. That's the factored form. Part C, this is a special form called vertex form. Vertex form. And the general formula for that, y equals a times x minus h squared plus k. And we've already talked about transformations. So if it makes a parabola, you know that h here shifts it left, right, and the k shifts it up, down. Okay, so there are benefits and disadvantages to each one. The benefit for standard form, based on this graph, you can easily find the y-intercept in standard form. Easily find the y-intercept. So why is that? Well, to find a y-intercept, you know all you have to do is plug 0 in for x. So the y-intercept for this will always be 0, c. Because think about it. If you plug 0 in for x, that goes away, you just get like y equals c. So that's what's nice about standard form. You can find the y-intercept really easily. In fact, for ours it was 2.5. In our standard form, look, c was 2.5. So that's one of the perks of standard form. It's not easy to find the zeros, though, necessarily, and it's really not easy to find the vertex. So what about factored form? Well, obviously, right away you kind of look at it and know what the zeros are. So that's one of the perks of factored form. You can easily find the zeros. They're kind of staring you in the face. You just solve each one at 0, and you got your answers. And then vertex form, I hope that one's obvious. You can look at it and know where the vertex is. I mean, our vertex was at -3, -2. Look, shifted left 3 and down 2. So I know that h value is always the opposite. So that's the perk for vertex form. You can easily find the vertex. One other thing I didn't add to this, but also it's really pretty obvious what the axis of symmetry is. If you know the vertex, the axis of symmetry is really obvious. It's like x equals a number, and what do you know? X equals -3. The vertex was at -3, -2. So also, vertex form really helps you with axis of symmetry. Okay, the vertex would be h comma k. So h and k, just notice it's the opposite sign for the h. That's where the vertex would be, h comma k. And then the axis of symmetry would just be whatever that x value is. So x would be h for the axis of symmetry. And then one quick note. I want you to notice, this is the important part. Whatever form you're using, they all use the same a value. They all use the same leading coefficient, or you can call it the a value. So I'm going to add little pink arrows in here. So whether you're using standard form, or factored form, or vertex form, they all use the same a value. That's important when we go to solve different kinds of parabola questions or quadratics. So whether you vertex form, factored form, or standard form, they all have the same leading coefficient, all have the same a value. The rest of their math is not affecting that. Quick note that you should remember from Algebra 2, if a is greater than 0, aka positive, the parabola opens up, which means it would be concave up. And then if a is less than 0, or negative, the parabola opens down. Or you could say concave down. So my second example here. Here's a parabola, y equals 2x squared plus 2x minus 12. And that's standard form. So I want to know some critical points about this thing. Right away, you could tell me the y-intercept. Look, plug a 0 in for x and solve. It's just going to be -12, because that would go away and that would go away. So y-intercept you can know already is 0, -12. Okay, so what else can we get out of this thing? Can we know the zeros? I mean, maybe if we could factor it, we could know the zeros. So if I factor this, let's take a 2 out front. I get x squared plus x minus 6. And then I can get this x squared plus x minus 6 piece. I can factor that. X plus 3, x minus 2. So right away I know my zeros too. I know my x-intercepts would be at -3 and +2. And this is factored form. So my zeros are at -3 and +2. So I want to make a quick sketch here. I know I got to go down to -12 for the y-intercept. And then one quick note I want to make. Just because the y-intercept is way down here at -12, so go ahead and sketch this graph. Just because the y-intercept's way down here, and maybe it looks like we're really kind of stretched out, that doesn't mean that that's where the vertex is. So if you look, the width between these 2 points, that's -3 to 2. So maybe I'll use a little highlighter here. The width between those 2 points, -3 to 2, that's 5. So then the axis of symmetry should be halfway between there, right? Symmetry means you cut it perfectly in half. So if it's 5, I guess that means you should be 2.5 away from each side. So for example, if this is -3, then the axis of symmetry should be right here at like -0.5. So that is where axis of symmetry would go. X equals -0.5. So the vertex would actually be down here at -0.5, comma, well, I guess whatever you get when you plug in -0.5. I'm going to leave it like this for now. So I didn't find the vertex yet. I'll leave that to you. Plug in -0.5 for x, see what you got for the y. That would be your vertex. Okay, last little bit here. So just to remind you, for a quadratic function in standard form, it's not obvious sometimes what the zeros are, like in factored form, but there are two ways that we could solve for them algebraically. First way is factoring, and if you can't factor it, any quadratic, you can always get the answers if you know the quadratic formula. So that's just a reminder on those two pieces. Okay, last example here. I'm going to give you a scenario with a few points and see if you can come up with the equation of the parabola. So, find a formula for the quadratic function with zeros. It's got zeros at x equals 2 and x equals -4. And it's got a y-intercept of 10. So this is all the information I give you. I want to see if you can come up with a parabola. And if you think you can do it, go ahead and pause the video and try that now. So where I would jump in is, well, I know that x equals 2 and x equals -4. I can write those as factors. So I'm pretty much going to look to write this thing in factored form. So x equals 2, the factor it must have came from, if we can go backwards, that must have come from x minus 2. And x equals -4, that must have come from x plus 4. So I know those two factors. So I'm going to look to put this thing in factored form. That's going to be the easiest right now. So I got x minus 2, x plus 4. And then here's the key that everyone always forgets, is we don't know exactly what the a value was. That could be anything. And if you forget and you just like don't put anything there, like I'm covering up with a hand right now, if you just leave it as x minus 2, x plus 4, plug a 0 in for x and see what the y-intercept would be. The y-intercept would actually be like -8. So we need to find the correct a value. People always forget that part. If you just left it as a equals 1, the y-intercept would be 0, -8, and that just simply is wrong. So that gets a sad face. So how do we get the right a value? We got this equation, we got the two zeros correct. Well, you still have one piece of information we haven't used yet. That would be y-intercept of 10. That doesn't mean just plug in 10 for y, because this is like what you need. You need to account for this x, and this y. Well, the y-intercept of 10, that's actually telling you about a point on the graph. So if the point on the graph is 0, 10, why don't we use that for the x and that for the y, substitute in here, and we can actually get the a value out. So let's substitute. We need to substitute a point for x, y. I'm going to plug in 0, 10. So now look, where the x's were, I put in 0. I even color-coded it because I got it from this green point up here. And where the y was, I plugged in a 10. And I'm going to have to get rid of my sad face here because it's getting in the way. Okay, then this math actually should be pretty easy. That's -2. Do the parentheses first. -2 times 4, so that's -8. So 10 equals a times -8. Divide by -8 on both sides. And let's simplify that fraction a little bit. This is -5/4. So that's really the tricky part here. People always forget to actually get the correct a value. So our final solution, now we know what a is, we know the whole formula. Y equals -5/4, x minus 2, x plus 4. And if you don't believe it, plug in 0 for x right now, and I guarantee you get a y-intercept of 10. That's how you can check this. Alright, that's all for these notes. I'll see you in class.